Hi everyone, now I'm going to talk about today's assignment. We use the same dataset as Monday. From here it's the same as Monday's assignment. I import some library and import the dataset. Here I made some changes because we need to choose the five attributes that related to result. Here I choose season, year, week, trap type, and numbers of molecules and species. And so here I transfer the trap type into numerical type, also the result into numerical type, and the species into numerical type. And then we got the five attributes that are related to the result. And I assign them to X. As for Y, I assign the result numerical type to it. And then I split the dataset as train set and test sets. The test size is 0.22, which means the test size is 25%. And the next step is to build a naive Bayes model. For this model, I import this model from Skylern and fit in the model with X-train and Y-train, get the predictions of this model, and then is the evaluation of the model. The first is to calculate the accuracy score of this model is 89%. It's not a low number. And then I plot the confusion matrix. And then I generate the classification report. We can see the model can predict the zero value very good. It's 93% precision. It got 93% precision score. But for the value 1, it doesn't predict very well. It only has 0.38. And the second model is random forest. Here I also import the random forest classifier from Skylern, and I set the numbers of trees equals to 100, and the criterion is entropy, and fit in the model with X-train and Y-train again, and get the prediction. Then is calculate the accuracy score is 0.92. And then is the confusion matrix and the classification report. Here, for value 0, it has performed the same as naive Bayes. The precision score is 0.92. But for the value 1, the random forest predicts 0.70 for precision score is way much higher than the naive Bayes predictions. And also the accuracy score for naive Bayes is 0.89, but for random forest the number is got higher at 0.92, which means the random forest is better than the naive Bayes in this dataset with these attributes. That's all. Thank you.